How do you find the value how do you solve this logarithmic equation? The first thing that you should notice is that there are no two logs on both sides. Right? There's in fact only one log with the base 2. Right? So you want to get rid of this log if there's only one. To get rid of it, you introduce a base 2, right, and have the log as the power. Log 2x minus 14. And remember, when you do something to one side, you have to do it to the other. So the same base 2 raised to the 5th power. And why did I think of 2 specifically? What gave me that 2 is this base here. This base tells me that I should raise it that I should have this base 2, right? Because when we have a base 2 and we have the base of the logarithm, we know that these two bases will make sure that the answer will be this, right? This will be the resulting expression, 2x minus 14, right? So this 2 log with base 2 will disappear, right? So that's another power rule of the logarithm that you should recognize, right? So this means that it's going to be what? 2x minus 14. So you see, it's that easy. It's going to be clean 2x minus 14, and these two guys, 2 log with base 2, will disappear. Right, so 2x minus 14 is equal to 2 raised to the 5th power. 2 raised to the 5th power is 32. So now solving for x, we will have what? We will have 2x is equal to 46. Dividing both sides by 2, x is supposedly 23. So now we have to make sure that this is a solution by checking it in the original logarithmic equation, right? So it's going to be log base 2 twice 23, right? So it's going to be 46, 2 times 23, minus 14. So let's see if we get 5. So log base 2, 32, right? So what does that mean? Remember that in order to get rid of the log by having a 1 in the result, we have to transform this 32 and make a 2 be part of it, right? To make 2 be part of it, we know that we can set it being equal to 2 to the 5th power, raised to the 5th power, right? Because we know 2 to the 5 is exactly 32, right? So we know that the power will go down, right? So it's going to be 5 log base 2 input 2, right? Because the power comes down. So now this is the power rule of the logarithm, right? So the power comes down, and here's the golden part here. This will be equal to 1, and we know that by remembering that we can express this as log of the input divided by the log of that base 2. And since both of these inputs of separate logs are equal, it will be equal to 1, right? So 5 times 1 is equal to 5. So bingo, it does check. This is the same answer as what we should have had, right? So this is a solution to the original logarithmic equation. Thank you so much for watching. Hope this was fun, and see you in the next video.